Hey, happy Sunday. This is PFG Live, the podcast that asks you if it's that hard, somebody should be able to do it. Welcome aboard. We got a bunch of good folks in both the Discord server and on the YouTube. CJ Stevens is reporting in at 52 degrees, 62% relative humidity with plenty of sunshine in East Tennessee. Welcome, CJ. We have DBX reporting from near White Plains, New York, where winds are 290 at 21, gusting 32, 10-mile visibility. Kind of windy. Dale is reporting in from the Edmonton of the Alberta, minus 13 degrees science, and finally stopped snowing. They got 6 inches in the last 36 hours in Snow, Mexico. Evils in Ghent, Belgium, says it's 21.9 degrees and 9.5 degrees science dew point in his lab. Okay, Jamie Jamie DCO, we're going to have to decode that one of these days, sent a full METAR for Johannesburg, and I can't read it. It's so small. So, you're better off pasting the raw METAR data right into the chat. It's way faster. Bill Olney is with us in Rome, New York, home of Air Force Research Labs at 39 degrees and thinking about raining. Tucker in the Buffalo, New York says it's 45 degrees Fahrenheit and partially cloudy. And Mike Rowe Machinists, also known as Adam Demuth, says it's 46 Frankenstein and he has not seen the sun in a week. Okay, Jamie. Cool. Who else is jumping in? Andrew Deere from Salem, Oregon. Welcome, sir. 47 degrees Fahrenheit and drizzling. I never heard of it drizzling in Salem, Oregon. That's unusual. Very unusual. Welcome aboard from Windham, New Hampshire, where we're near the Manchester Airport, which is reporting winds are 290 at 15, gusting 26 knots, visibility 10 miles, broken at 5,500, temperature 08, dew point -05, altimeter 29 or 67. Remarks, peak wind was 300 at 33 knots at 1813. That's crazy. So welcome aboard. It is, in fact, Sunday. In fact, it's not only Sunday, it's the Sunday before Thanksgiving here in these States United. So if you have a kitchen, it's probably cooking something. So we're looking forward to visiting Mom and seeing the sister and having everybody together, and we're going to have a good time this coming Thanksgiving. Since we last met our heroes, we've had some stuff happen. DBX asks, did I get the oven door back together? So let me explain to you what happened today, because I think it's worth sharing. Our oven door started acting a little funny. We have a Wolf, I guess it's called a 36-inch dual fuel, like the oven is electric and the cooktop is gas, and the oven door started not fitting quite right. Josh says it's 42 degrees inside, warm enough. That's am I reading that right, Josh? Josh, of course, is near Winnipeg in Canada. So oven door not fitting. A dutiful, beautiful, gorgeous wife says, please make oven work. So while nobody was home, I took apart the oven door. I observed what was wrong, and what was wrong was there's a gas shock that has just lost its poop. So we're going to get a gas shock and replace it. But before I started the podcast, I had to put the oven door back together again, even in its compromised state, such that cooking may proceed. So Evils reports that to add to his weather report that there was enough tailwind on his bike that he made it in time. That's why you hold your jacket open while you're on the bike. Excellent. I think that's Leonardo from overcast London. Welcome, sir. Bloody windy. Well, I'm glad you were able to make it. So Josh clarifies, near Winnipeg, it's 13 degrees science inside, and -9 degrees outside and very white. Right now, it is 45 degrees outside Fahrenheit. I can't make this stuff up. It's crazy, crazy weather. So yeah, the oven's back together. Honorable wife can cook some stuff. It's just not perfect. So we're getting there. Okay, Jamie is now checking in from Johannesburg. Says it's winds are 330 at 5 knots. Visibility is okay. 22 degrees science, 11 degrees science dew point. Welcome, sir. So this week was weird. I think I say that every time. Do I say that every time? I think I say that every time. So in the slide, the thumbnail for today's show, you're excited because Aaaand Demuth is going to be on. I know, but also I indicated that I dumped ShipStation. Now, as you know, I sell stuff, and I have to ship stuff. So in selling and shipping stuff, we use a piece of software. It's really software plus services that lets us automatically import the orders from Squarespace, which is where our website and our store is, and it will generate labels for us. It puts up the order, we fill the order, put it in a box, tape up the box, hit the button, prints a label, automatically goes out and pays for the shipping, does all the right things. If we need insurance, it does that. Gives us a label, we slap the label on the box, and off it goes. And then usually I take it to UPS, post office, whatever. Well, a couple of years ago, weird things started happening. And in particular, the weird things were noted because of my wonderful Canadian customers. So in shipping to Canada, it turns out, and only Canada, I'm not speaking about any other country, UPS was the death knell, because UPS would somehow, weirdly, put these broker fees on a shipment, just jacking up the price, and those broker fees were paid by the recipient, and their stuff was held hostage until they paid the broker fees, which were usually more, significantly more, than the cost of shipping, and had nothing to do with duty. So UPS was out. So my Canadian friends said, please ship USPS. And I said, no problem. So we started shipping USPS. All of a sudden, one day, I note that our USPS label had some extra stuff on it, and I read it, and it's going to go to a center and then be put together, agglomerated, and then sent over the border. And that service was called Global Post. And I was led to believe, and I don't remember how I was led to believe, that USPS, United States Postal Service, was contracting with Global Post. I didn't think much of it. And it worked somewhat, but then it started getting anything that went Global Post, Canada or other countries, was starting to get horrible. And the delays were very long and lost packages. And on the third lost shipment, I said, that's it. So I start doing my homework. What do you know? USPS did not subcontract to Global Post. Okay. ShipStation made the decision for me that they would send my stuff via Global Post. So just to shorten the story, 3 times I had to contact customer service, and they said, oh, that's because listen to the words, you are opted in to our Global Advantage program, and we use Global Post. And I'm like, I didn't opt into anything. If I say I want it to go global post, it should go global post. If I say I want it to go USPS, it must go USPS. And they said, oh, we'll take care of you. We will check the right check boxes on your account and it will fix everything. Well, all of a sudden, I started getting offered both USPS and global post. And I was able to choose. Of course, for my Canadian customers, there was only one choice, and that was USPS. Suddenly, my labels looked different, and they were USPS labels for Canada with all the custom stuff, and everything was great. For a while. And then it broke. Well, fast forward to the most recent breakage, which was roughly a week and a half ago, and I get an order from Canada, and I hit the button, and up comes another label, and it said Global Post, and I was pissed off. So I get on with customer service, and I'm doing the chat, and they said, oh, well, yes, we have to change that for you. This is customer service. We have to change that for you. I said, why do you have to change it for me? Oh, well, we'll take care of you. So days ago, okay, I'm talking with somebody by the name of Aiko, A-I-K-O, and his last initial was A, Aiko A, or Aiko A, I'm not sure. And he basically said, no, we will take care of you. I have these check boxes on your account, and I will set it correctly. So he says, I have unchecked the global post, and you won't see it again. Now, I apologize if you're on audio only today. I'm going to show you on the camera the screenshot what they did. Okay, there's the screenshot. And what did he do? He unchecked all the USPS options and left all the global post checked. And he sent me this screenshot to prove that he did a good job. I didn't even know what to say. I did say some things. And then finally he said, oh, I'm sorry. I'm going to fix it. And then he sends me this screenshot, which is appropriately, focus, the global post turned off and USPS rechecked. And I said to him, and I'm paraphrasing, I have this transcripts right here. I said, so you're telling me that I can go make my label now and everything is going to work perfectly and I'm going to get what I asked for. And he said, well, first, our supervisor has to approve it. And I'm like, excuse me? And I got some more nonsense. So I said, look, I'm going to go have dinner and I'm going to go to sleep and I'm going to have a lovely evening and I'm going to wake up tomorrow. And when I get to the shipping desk, I'm going to print this label. And if it says Global Post, you are fired. Guess what happened? I got a Global Post label. 3 times, by the way, a total of 3 times I printed Global Post labels and voided them. And finally I said, that's it. By lunch the next day, I had a Shippo account, another supplier. Okay. You could look them up, check them out. And I made my labels exactly the way I wanted. And I had a working connection to a shipper or a shipping services provider called Shippo. And they did a great job. And I got exactly what I asked for. And they were gone. ShipStation was gone. Fired. Account canceled. Done. Dead to me. Now, let me explain to you why. Because Stamps.com owns ShipStation. Where do you buy your postage from when you're using ShipStation? Stamps.com. Stamps.com owns Global Post. Okay. All of them are owned by Thoma Bravo, which is an investment firm that owns Stamps.com. So basically, ShipStation was forcing you to use Global Post, which they owned, without being clear about it, without, and forcing you to opt out of that if that's not what you wanted. Does that sound like a shipping service that is being responsive to its customers? I don't think so. I think it's borderline fraud, okay, and absolutely misrepresentation. Fired. So I did a post on Instagram in which I said some of these words. What do you know? I get an email from Justin. Justin, how are you? If anything I said here, Justin, is non-factual, you let me know. And Justin says, this is not how we are. We're terribly sorry. I'm going to look into this. And I sent an email back to Justin. I said, don't bother. You're fired. You're gone. I'm out. And he said, something, given your experience, I don't blame you. I'm sorry we couldn't blah, blah, blah. Nice words. Goodbye. Justin, it was a horrible experience. Now, I just want to point out that I have been a ShipStation customer until I canceled since June of 2020. So that's 4 years. And now I am out of here. Shippo seems to be a good service. Time will tell. Simple, gave me exactly what I wanted. The labels are actually much clearer and print better. Seems trivial, but it's not. And I'm happy. So I don't like being negative, a negative Nelly, but I do think when somebody acts that way, when a corporation acts that way and misrepresents what they're doing for you and who they are and who they represent, that I'm going to call them out. And I told Ico A that I was going to make the conversation famous if I got another Global Post label after waking up that morning, and I did. And I have, and I'm done. So I'll give you an update on Shippo, but, the first morning with Shippo, I shipped to Canada. I shipped to Switzerland. Everything went smoothly. I was very happy. I feel better now. I feel like I've unloaded. Thank you for listening. I appreciate it. This is like podcast therapy. So, after I got over that debacle, I got to thinking about things that I want to learn about and what we should do with the podcast. And something smacked me right in the face, and that was this topic of hard milling. Now, probably the reason that it smacked me in the face was Mr. John Saunders of Saunders Machine Works and NYC CNC was talking about hard milling with John Grimsmo of Grimsmo Knives on the recent bill of materials. I'm sorry, the recent Business of Machining podcast. And I think it got into my head, and I'm like, I want to learn about hard milling. So I think the best possible person to talk to is Mr. Aaaand Demuth. So I'm going to bring in Adam and say, Mr. Aaaand Demuth, hello, how are you? I'm not getting your audio. You are muted. No, you're muted in Discord. I could unmute you probably.
How's that?
That's perfect. See, that's how you know you're actually having a meeting, is when the words "you're muted" have been uttered. Welcome, Mr. Demuth.
Before we get going on hard milling, I have a new shipping situation with McMaster,
Please.
Which is as long as I order it before 6 p.m., it arrives 6 a.m. the next morning via milk truck, and it has been life-changing. Just how quickly you can do things now, like when at the end of the day you get an email from the West Coast and you can have the material in hand the next morning. It's been really really good. So it's not all bad in the world of shipping, I guess, is what I wanted to contribute.
Yeah, absolutely true. And that for us, it's UPS. I think I've gotten both UPS and USPS. I'm not sure, but absolutely, McMaster car is miraculous.
So that's just been a really huge thing for me the past month, is how quickly I can get moving on a fast project because the material's here the next morning.
Yep. And how you don't have to have that stuff sitting on your shelf.
And it's cheaper than their UPS rates.
Yeah.
It might be like $8 to get a box of, random pieces of metal here, and I can't hardly believe it. So
yeah. Well, thank you for good news. I was getting to be a little negative there, but that was very positive, happy, uplifting news. Proteum says they started shipping free Saturday delivery here. That's in Phoenix. Tucson. Though UPS fakes trying to deliver it and says undeliverable. I've had some of that in my shipping where the other end says delivered to package box.
I've caught my postal worker red-handed. They were putting the slip in my box. I go, "Oh, hey, I'm here. I can take delivery of it." And they go, "Oh, I don't actually have it on me." So they had no intention of ever dropping the package off. So I avoid USPS for getting things to me.
Wow.
It seems like if it's like over a pound, they just leave it at the post office and I have to go pick it up.
Robin's here. He says, I get Friday McMaster orders delivered Saturday always. Isn't that crazy? Yeah. Welcome, Robin. Yeah, I like the fact that not only do we get our McMaster stuff fast, but they have the clout to figure out what they have to do to make it happen, and they seem to do that. And they seem to be very responsive. So, I welcome you, sir. Nice to see you. We have
hard milling.
Hard milling. Compared to you, I am a milling newbie. I mill stuff. I have a CNC machine. I crank out production things. I make my balancing rings. I do engineering prototypes, and I have an intuitive understanding of, I'm going to be milling steel, and I'm going to be grabbing these carbide bits, and it's all pretty normal. As soon as I think about something that's Rockwell 60, I don't know how to approach it.
I would say, with the exception of like your technical ceramics, if we just kind of put some boundaries on this and keep hard milling to the discussion of tool steels like mid 60s and below, it's pretty approachable. And you get this idea that hard milling is going to be a high-speed machining center, going just lightning fast feed rates and micro end mills. But it can be very slow and just, like a few inches per minute feed rates, and within mills that don't look all that dissimilar to current end mills you're using. So it's not always a fancy machine like a Kern doing it. Some of my early introductions to hard milling were on a SIP jig borer, and it has a max RPM of 2000. So slower spindle speeds can be used when hard milling. And then the second thing I wanted to lay out is like, where does hard milling begin? What's that Rockwell hardness? And that's always it's moved around on me. Just kind of throwing out like 40 Rockwell. There's a lot of off-the-shelf products in that 40 to 44 Rockwell, steel-wise or stainless, that you can buy as bar stock and process. And with the exception of some like high-speed steel drilling, you could still process them with the standard tools in your library. The end mill you use on 1018 and 4140 is still going to cut that pre-hard 44 Rockwell tool steel you're cutting. So I don't feel like low 40s is all that hard. You get up into like the high 40s, low 50s, all of a sudden a lot of your drilling and thread making and reaming solutions that you have in your library, they no longer work. and some of your milling might, but you're going to see a lot higher tool wear. And so maybe like 48 Rockwell, I guess, is where I'm starting to really think about hard milling approaches, and more specifically hard milling tooling as being a necessity.
Yeah, I've gotten 4142 pre-hard. That's actually a favorite material here. And we've measured it from 36 to not quite 40. And with carbide, standard carbide inserts and stuff, it really actually, not only does it do a good job, it does a great job. But like I made, I issued homework to everybody on Discord to watch your video on the thin V block, and that's harder. That's running Rockwell 60. Am I right?
Yeah, it was probably 58 to 60. That's where I spec a lot of, when I send it to heat treat, that's where I spec a lot of like non-load bearing tooling for A2. So if it's just like a holder. And that's getting into the realm of hard. Like anything 60 and above, you're gonna see a lot of like tool wear, and you're gonna really have to stay on top of it. But in the 50s, you'll find hard milling is quite pleasant. Like 58 or below, it really goes very, very well. But I also wanted to add, like, go to your toolbox and grab the nearest carbide end mill, and you have a hard milling end mill in your hand. It's really just a battle of like who's harder, and carbide usually wins that against tool steel. But it's just hard milling end mills are designed to last. They have different coatings. They have different tool geometries that supports the edge better. They have shallower flute gullets, and that's the difference. Along with that comes cutting approach strategies that are different. You're not going to be taking a slotting, full depth slotting pass with a hard milling tool. You're going to be taking these light step downs, and so it's a culmination of slightly better tooling, more optimized for it, and better tool path strategies.
Well, if you're not chasing optimal production efficiency, like tool makers aren't, can you have the same tools for quote normal milling and hard milling and not have to have special tools?
I have a few that kind of double duty, but they're both finishing. I've not found a lot of tools that rough, like just, sometimes I grab a plate of pre-hard tool steel and make a part directly from that versus milling it in yield, sending it to heat treat, finishing it. The tools that do the roughing I have not found are very economic when roughing, say, 4140.
Got it.
Because they have that shallower flute gullet, and oftentimes they have less length of flute. So in terms of metal removal, they are kind of limited based on those design attributes. So I've always just kind of had the approach of two libraries. But I'm kind of lucky in the fact that I have this machine and that machine. This one does most of my milled stuff. This one does most of my hard stuff. So it's not like each machine has two libraries. It's a little easier that way, I guess.
So let's talk. A question popped into my mind is do you think about the ratio or the difference between the material you're milling and the tool you're using, and is there a difference that gets so close that you got a red alert go off and say, wait a minute, this may be really hard or really difficult? Sorry.
No, because I don't spend a lot of time. I find like hard milling in the mid 60s and above, like your exceptionally hard tool steels and like your stuff like that. That's a really not fun place to be because your tools just are wearing down so quickly. But I don't spend a lot of time in that area. I'm either making a very precise holder or the insert which is technical ceramic. And once you go into technical ceramics, you're using a different suite of tools to address that problem. But yeah, you get into like the mid 60s, and you're starting to see the challenges. And it's not like you can just buy your way out of the problem. You're using a very, very hard material, and your cutter isn't all that much harder than it.
So you use some CBN tools in that video.
Mm-hmm.
So we have CBN, which is some people may not be familiar, is cubic boron nitride, and that's not as hard as diamond, but it's in the family, right?
No, but diamond has a problem in steels where it's like carbon on carbon,
right?
And I guess it doesn't like that when you add heat. Whereas CBN doesn't mind steel at all. So usually it's, your technical ceramics, you're going to be diamond, and your steels, you're going to be CBN.
Okay, and that's the top of the hardness scale for the tools, right? Is CBN tools.
Yeah. And if you have a part that can justify that, it I don't know, usually goes pretty well. But that's not something I reach for often, job shopping. But again, I see this gap. I don't deal in the realm a lot where CBN's the answer. It's either I'm in diamond territory or in that 62 and below area. So
gotcha.
And you see that a lot in tool catalogs. They'll have solutions that go up to 62. And then the companies that really specialize in hard milling might have like a 66 to 70 Rockwell solution. And it's an entirely different tool.
Now, when you say that, you're saying a solution for cutting materials at 62 Rockwell or whatever.
Yeah.
Okay. So now, just for reference, our favorite carbides, our standard carbide tools, are where would they fall as far as how hard can they cut?
I cut a lot of carbides that are like in the 88 to 90, maybe 92 Rockwell area.
Okay, that's the tool itself.
Mm-hmm.
And then if we drop down, go ahead.
Oh, I'm sorry. You go ahead.
If you drop down now to high-speed steel, a high-speed steel tool is going to be coming in at 65, 70, or maybe not quite that high.
I've never really had to pay attention to high-speed steel hardness because I'm not using it in stamping applications.
Yeah.
So it's not really something that's on my radar.
Okay, fair enough. But those are sort of we've established the three families is like high-speed steel, carbide tooling, including inserts, and then we get into the CBNs and maybe even diamonds.
Yeah, and there's some like weird stuff with ceramics. I don't really mess with that, like green leaf. But and that's probably going to be like up there with your diamond and CBN in terms of hardness, but that's not really my world.
So Evils asks a question. He says, CBN and diamond in milling, are those coatings or inserts? And I think we're talking about inserts or the actual.
Well, so in my world, most of my milling is 6 millimeter shank and below, and so that's either going to be a coating or the tip is entirely diamond.
Okay.
Or CBN.
Okay.
And it's brazed into position.
Dale WidgetWorks has said that HSS high-speed steel is around 63 to 65 Rockwell. So that frames.
Well, there we go.
That frames it for us. And the Cobalt high-speed steel M42 is around 70 Rockwell. So that frames things. So what do we need to know? How do we go from wanting to do hard milling to making very tiny chips?
I guess it would come down to what you're trying to accomplish. So different operations are going to have different tools, and the tools become quite specific to your goal. So if you're taking a perimeter cut around a shape, and you're just, cleaning up the walls of the part, your tool really isn't going to look that different from, like, this is a standard end mill, for your whatever steels you're cutting, and this might be the hard milling solution. You usually see a slight difference in coating. Sometimes they have more flutes, sometimes they don't. But the key difference is the depth of the chip flute. They want as strong as a core of carbide as possible. You'll see some stuff with the flute angle or the cut angle because they're trying to reduce deflection. And you'll see like what looks like a very sharp edge. The cut angle is well supported, but again, they're trying to reduce deflection when you're using like a long length of engagement like this. And this is like where hard milling isn't necessarily a high speed situation. This might be going like 800 RPMs, very like slow surface speed, and then you're just progressing like a 1 thou per flute chip load around your part, and it goes extremely slow, but you get minimal wall deflection, you get really nice finishes, and if you have something where you're worried about it growing in heat treat, one operation cutting it after heat treat, it's now dead on size. You don't have any heat treat scale or anything like that. And so that's like your most basic hard cutting is just a 2D contour. A lot of hard cutting I do, the corner radius of the tool is no longer just something there to make the tool stronger or maybe make a part corner stronger. That corner radius is now cutting geometry. And you're doing like a 3D step over a wall and a surface and an angle, and you're using that tool radius as part of it to get it to size. And so any variation on the size of that corner radius of the tool is going to either leave or remove more stock. And so you see a lot of bullnose end mills for hard milling are shockingly expensive, and that's because they're having to maintain size on these corner radii, whereas on a regular milling tool, it's maybe plus or minus 20 microns, or a thou. It's not something they're super worried about, and that reflects that in like their catalog. It's usually like a 2 or 3 decimal place call out, like a 0.02 corner radius. Whereas the corner radiuses I have on my end mills, they're held within 3 microns. So, it's just suddenly little things start to matter when you're doing these different toolpath strategies.
And who would be those manufacturers? Like if you had a name between 1 and 3 of your favorite manufacturers for that.
I use NS, Union, and Fraser a lot. Also Mitsubishi, Imugi. Sure, I'm forgetting some, but you'll find a lot of them are Japanese. They really kind of excel in that market. And then Fraser's kind of German US. Yeah, and then the diamond stuff, NS, they make a coated diamond end mill, and they're reasonably economical, but the coating has a lot of variance in thickness, and that becomes problematic when you can't comp a ball mill on a lot of controls. You can comp the length, and you can comp the diameter, but if the radius is different, as it goes over, it's going to leave weird stock conditions as it goes over an edge like this. The top and the side might be fine, but it's anything outside of that. And so when you have a tool whose ball diameter form is constantly changing from tool to tool, to combat that means you have to adjust your cam file per tool. And so if you're doing like a series of parts, it gets really frustrating to have to repost your cam toolpath every time you change your cutter.
That's an interesting problem, and yeah. So, but you pay for that accuracy, obviously. What do you think the ratio is between a quote standard tool and one of these high accuracy specified tools?
Just based on like the kind of standard library tool I use for 4140 and below, it's a Kennametal 6mm 4-flute tool. I think it's like 20 millimeters of tool length, and it's like $40. That same tool optimized for hard milling, it's not going to have that amount of tool length. It's going to have a very precise corner radius, and the cutting diameter is going to be very precise. It might be pushing 80 to 100. So I think throwing like a 2 to 3 times multiplier on it to go into a hard milling class of tool is fair.
Okay, fair enough. Robin brings up, he mentioned polycrystalline diamond PCD, which we didn't mention. So now we mentioned it. And Zetcha, is that a manufacturer you're familiar with?
Yeah. And so Zetcha's tools, at least some of them, like their thread mills, those are actually made by Union.
Ah, okay.
I know they now have a solid MCD tool that they're laser ablating. And that's going to be like similar to a 6C tool. And from what I hear, it's supposed to be pretty promising. But yeah, I know for a while a lot of their carbide offerings were Union.
So, okay, I go to the websites, I find the tools. They probably have speeds and feeds for hard milling. Am I correct? Is that pretty easy to find?
Yes. Yep.
And can we trust them? Do you?
Yeah. So, 1 second.
Okay.
The difference between like buying, just whatever tool on Amazon and deciding to build out a tool library with a brand is those higher end tool companies, they don't have just like a catalog, they have a user's manual for their tools, and they can be quite thick.
Wow.
And that's what you're getting into when you get into bed with some of these hard milling companies, is you get an immense amount of technical wealth for how to run their tools. They want you to be successful with them. And for me, as like a job shop, the sneaking up on size can be very expensive. And so to have the confidence of being able to take a routine, which I have templated in CAM, load a tool, which I know is going to be within a few microns of the corner radius, and just run it. As Dylan points out, a lot of these companies have a web app as well. Not so much the Japanese companies. They're very paper-oriented, but yeah, Frasia has one that's quite good. And so you gain a lot of confidence going to like a very well-controlled tool when its radii and diameter are so precise.
Yeah, just for the audio guys.
Yeah, NS gives you an Excel doc.
For the audio guys, Dylan at Prody Machining is saying that Frasia's Tool Expert app for speeds and feeds works incredibly well. That's pretty neat. I'll have to check them out. So, all right, I get my website for one of these guys. I get my tools. Do I need anything special for tool holders?
I end up running something in an ER16 every now and then. It's not ideal. I do prefer to have it in a hydraulic holder. That's kind of what I found works best for the amount of change out I have in my shop. I do have a couple jobs which are very static and returning, and so I run those in heat shrink. You want minimal run out, good stiffness. In my machines, like short gauge length. I find that to be helpful. And since I'm not doing 5-axis work, I really don't need those long holders. You want to help out the cutter every way you can there. But you also want to think about chip evacuation. Most of the time it's going to be air. And so if you're doing something like thread milling and you have a huge hydraulic holder like this, holding a very tiny thread mill, that's not sticking out very far, you might not be able to get air into that hole to evacuate the chips. Neither of my machines have through spindle air or coolant. So sometimes going to a slightly smaller holder that lets you get a nozzle closer in, that helps things.
Interesting. And do you wish you did have air on your machines?
Definitely on this one. I think that would have been a worthwhile upgrade. But most of your high-speed mills tend to have like glass scale packages and air oil mist spindles. And just sitting, they're just going through immense amounts of air. I think this one, it's around 12 CFM.
Wow.
Just, running, And so on days, I have an air nozzle on this one and on this one. And days where I'm using the air nozzles, it seems like the air compressor never really shuts off. So I do look at air usage in my shop, and it's by far the biggest cause of electric bills.
Wow.
High ones.
Yeah, 12 CFM just kind of hanging out is a lot of CFMs. That's pretty amazing.
Yeah, it's just like the spindle's constantly being purged, your tool laser's being purged, all the glass scales are being purged. There's, a lot of automation on the ATC that's all air actuated. So,
amazing.
Just high-end mills can be a little dramatic in that regard.
So what's your favorite tool holder?
I have some big Daishowa hydraulics that I really like. They're $900 a piece, though, so I gotta have a justification for that. But they're sub-micron runout.
Wow.
My heat shrink holders are also half micron runout, but they're a third the cost. And what's interesting with the heat shrink holders, they're sold by the name escapes me, but they have them in all different grades of runout, and I think they're just sorting.
Yeah,
like it's all the same product, and they're just measuring and billing accordingly.
Yeah, they're binning them.
Yeah.
So a good tool holder. What kind of RPMs? Now you said earlier that really the RPM requirements are pretty modest. Is that?
Yeah, and you can certainly get a high speed toolpath going with a lot of spindle RPMs in some applications. If you're using like really small balls and you're kind of like near the center of the end mill, yeah, you could really be turning them. Most of my stuff's pretty prismatic, where I'm using an end mill to cut on the sides of the parts and maybe face, and then I'm doing just a little bit with that corner radius. So I can't get too much RPM out of them based on just that. But if you're doing just like I said, 2D contour work, I'm in inch world. I could kind of go back and forth with inch and metric a lot, but in surface speed, I struggle with metric conversions on the fly.
Yeah. So
it'd be like maybe if I'm running a end mill like this, I might start at 100 surface feet.
Oh, okay.
Which that's pretty slow. And so I used to do a lot of hard milling on a CNC decal, and it had a 3150 RPM spindle, and I seldom got to the top end of that. So
Robin asks, general hard milling performance difference between the mini mill and the Morisiki?
So most prismatic stuff, it's not that huge of a difference. Any wallpaper you're seeing is tool related. There are some cases, like if you're getting into a lot of engagement, the drawbar on this machine with its HSK holder, despite being very small, is stiffer than the Haas. The mini mill has half the drawbar pressure of the regular Haas mills, and that does become kind of an issue when you're doing high deflection work. But where it does become an issue is when you're doing 3D work with a ball mill, especially where you're using the Z-axis a lot. If you have a kind of a concave feature and your ball mill is diving down and then coming back up, you're going to see a screw reversal in that finish pass. Sometimes you could do stuff about that with your toolpath and enforce like an XY routine where it steps down. Sometimes you can't. And that's to me the biggest thing is you see motion errors more on the Haas.
So let's back up a little bit because you're pointing out that the drawbar tension is a player. Did I hear that right? So
yeah.
So just some folks may not be totally familiar with it, but in that CNC machine, when that tool holder gets pulled in, it is under constant. There we go. It's under tension. It's getting yanked up into the taper by a pressure, and that's the drawbar. And if the pressures are different, it can have the potential for motion in the taper.
I'm not saying that it varies. It's just less than like a real Haas mill. It is a light duty machine.
Okay.
And so sometimes when you're running a long cutter on a hard material, you do notice more wall taper. Like the top and the bottom will be different,
Okay.
And that's because the whole holder is maybe deflecting out of the spindle a little. And so I kind of put a limit of like, this is a 40 millimeter length of engagement on a 12 millimeter diameter. And that's as big as I want to get on this machine. Past that, like you get up to like 16 millimeter or 5/8, you're going to start seeing some issues.
Protium says the BD hydraulics are so nice and a slim neck. Which is BD?
Big Daishowa.
Got it.
In the U.S., they kind of they merged their distribution with Kaiser boring heads, and they go by they used to went by Big Kaiser here.
Got it.
But it's really like two separate companies and product lines being sold by one U.S. sales force. Kooky situation, but really, really astonishingly good tools.
Dale says if you run high pressure through spindle coolant and you're working against the drawbar, and that can induce problems. Interesting. I guess you have pressures working against your other pressure, right? Doesn't matter that it's coolant pressure. Protium says, do you find blending easier between tools on the Mori? I'd imagine that without dual contact, you see some thermal growth issues more on the Haas.
The Haas does much better than it has any right to. Just like probing the tools and going, everything might be within 5/10, which is really, really good. I'm very happy with that. But yeah, he's absolutely right. If you're running your first of your 3 finishing tools for 30 minutes, you're going to see some thermal drift because of that. Whereas on the Mori, there's negligible thermal drift, like 10th maybe, and it drifts up if it does. And with the laser tool setter, I run a very long warm up prior to measuring each tool. It spins at 2 minutes at the tool's cutting RPM, then it measures, and that gets any spindle drift taken care of. And there's just not a lot of chasing Z comps. Oddly enough, you think about like precision machining, and you think about like tracking bore diameters and feature sizes. Most of the headache is tool length related. You're moving Z's up and down all day.
Yeah.
That's where a lot of the drama comes from. So,
well, if we look at, on any of these machines, if we look at the kinematic loop, that's where all the growth is going to take place, really. It could be a grinder, it could be a mill, it could be, right? It's that the column is just, it's going up and down like a yo-yo.
So a couple like key differences. So I've talked about like long length of a flute hard milling, how it's really not that different than regular end mills. A lot of the hard milling I do, I was saying, is on the corner radius with a bullnose end mill. And a lot of those end mills, they aren't straight. They have like a little bit of back taper to them.
Okay.
And it could be like a degree. It's not a lot, But what it allows you to do is to come down a wall, and you're only cutting with just a hair past the corner radii.
So that, I assume that's well specified by when you buy it.
It is.
Okay.
And what's really important, and all these companies do a wonderful job with, is this point right here, where the neck ends, and the angle coming off the neck. So for a lot of companies, if it's a necked end mill, that neck feature is like the side of the wheel. Like it's just, if the wheel's worn a little, it's going to be a little different each time. Whereas high-end companies doing ball mills for mold and die work, they're really concerned about that because they don't want that bumping into something when it's not supposed to. You know, and I've dealt with some, like, you know, Harvey tool, for example, where you kind of get complacent with one of their SKUs, and you might have it going so far into a feature, and then you get a new batch of end mills, and then all of a sudden something's rubbing because this moved down a hair. It's still in their called out tolerance, but it, you know, moved down 5 thou or something, and you're right at that limit.
Yeah.
So that's how a lot of their bowl mills work, and that's a common strategy amongst pretty much all the manufacturers, is this step down approach, where your step down might be a fraction of this corner radius, like 1/3, and you're stepping down, and you can get some really amazing finishes. And also what it does is, from top to bottom, you have the same amount of tool deflection. So on an end mill like this, it's the further you get away from the spindle, the more the deflection is. Whereas on an end mill like this, it doesn't matter how much it's deflecting, because as it steps down, it's still deflecting the same amount every pass.
Deflection, right? Let's see. Protium says, if you buy 5 Harvey tools, you might get 5 different neck relief angles.
The struggle is real.
The struggle is real. So, and I feel bad because they're up the street from me. they're in Maine. But if you said to Harvey, well, here's a question: if we said to Harvey, "Hey, I want you to hold the same, you know, specify the neck relief angles much tighter," would they do it? Maybe charge you more?
It's not even just that the relief angle's different, or the relief distance. I've seen different angles, Spencer, because it a lot of that comes down to it's not a controlled dimension, so it's like whatever the wheel's putting there. And a lot of that comes down to from what I've seen, a lot of those tool grinders have like a conversational almost software for getting the tool ground.
Yeah.
And so from like an Anka to a Star to, you know, United Grinding, that software might all result in a slightly different result there. And when you look at a company like NS Tool, they make their own grinders because they're so obsessive about details like that, and they want to be able to control all that. So this brings me to my next point on ball milling. So
hang on, let me just give a little reprieve here, because Protium says don't get me wrong, we use a lot of Harvey, just have to know what you're getting. Their hexalobe long reach end mills are much more consistent for long reach micro tools. Okay.
And I wouldn't be surprised if Harvey didn't make all their own tooling. Like, you know, if like somebody makes a better thread mill or something, or a drill bit, they just let that company do it. And the reason I say that is I have some drill bits from them, which are like an 1/8" shank, and I have some which are a 4mm shank. And I'd be extremely curious as to why one company would use an 1" and a metric shank for an inch-size drill in either case. And the only thing I can think of is it's a separate company doing the different product numbers.
Well, I don't want to go down the rabbit hole, but we do know that Harvey and Helical became the same company at some point, and there may be some of that still happening. But anyway, you go ahead. You were going to head off into another.
Okay. So in the ball milling world, this is like your standard, you know, cheap A-Trax, whatever, MSC 4-flute ball mill. You might grab it if you're having to put a bald feature on, you know, whatever steel. And if we look at it closely, see if I can... You see that little W feature?
Yeah.
That's gashing. Basically, in order to get the tip of two of the flutes sharp enough so they can cut, you got to sacrifice two other flutes. It looked like this kind of in paper. You're coming in here and you're trying to sharpen these two flutes, and you're losing this one and this one on like the bottom, maybe 30 degrees of cutting engagement of the 180 degrees.
Yep.
And so back to what are we trying to do with hard milling? It's usually we have a tolerance we're trying to hold or a surface finish we're trying to hold that's not going to survive heat treat. And so it could be like a mold cavity where we want a really crisp finish. And so what do you think happens when between a 0 degree plane to maybe like a 5 degree plane up to a 45 degree plane, you add two more cutter flutes as you're taking your 3D pass?
Well, without getting detailed, we know it changes. We know that it gets, theoretically it might get smoother as we go up to the steeper angles.
Yeah. But also this little gash sometimes is like a weak point and material can build up there. So the big thing with hard milling ball mills is a lot of them tend to be two flute. Unless you do see like some product offerings, every company has one. They're not as inventoried. They have less variety. They have less on hand, where they might offer like a 3 or a 4 flute, where it actually comes all the way to the center, but they're super expensive. So most of your hard milling ball mills are going to be like this, where it's just a 2 flute, and they do that because you get the same amount of flute all the way around the ball. So that's something to consider, is like the tools do need to be different if you're not just trying to cut metal, but like really have very precise features all the way around.
So it sounds to me like if you had your druthers, you'd rather have the 4 or 6 flute mill with the radius on the corners, rather than a ball mill if you didn't need it.
If I can get away with a bull nose mill like this, I really try to. I find them to be very useful because they establish a flat plane a lot quicker. So if you're like, let's think of like a receiver for an HSK interface. You have the flat and then you have the taper, and you're trying to ball mill both of those. It takes a long time taking very small passes on that flat portion with a ball mill. Whereas a bullnose mill like this, it's lightning fast. And I see a lot of stuff like that where I'm trying to blend a angled or curved surface to a flat one, and a radius bullnose end mill like this does that much quicker.
I am a complete neophyte when it comes to molds and things, so this is a newbie question, but can you go from a hard milled mold right into production, or do they always get some sort of blending, finishing work done to them?
If the surface finish the customer is spec'd out for allows that, yeah. A lot of times, though, designers get these mold texture packs, and it might be like, oh, that's a nice matte finish.
Yep.
And it'll literally be like Aggie number 6, and it's like a setting on a RAM EDM. And so just the choices designers make a lot of times force RAM EDM. But if it's just like, something in a breaker box, or it's a non-aesthetic molded part, yeah, you can absolutely go right in.
Cool.
And then there's like a lot of lens stuff, like say your cell phone case has a cover to cover the. That's probably going to get hand polished, but hand polishing has a lot of labor in it, and it has a lot of fatigue. There's a huge lawsuit with a big mold company and the makers of the hand pieces for Die Profile, the little reciprocating. Yeah. Huge lawsuit by a bunch of mold polishers because they all had carpal tunnel syndrome.
Wow.
And so a lot of people are paying attention to that. And it's like, well, it may take 40 hours, but a monocrystalline diamond tool kind of chipping away at an insert in a mold might make more sense than polishing that. And so you're seeing more and more stuff go to these exceptionally long runtime molding applications to avoid any handwork.
Wow. I wouldn't have thought of that angle. Proteum says, Adam, have you started to see more molding projects that have post-machining laser texturing? I seem to see a lot more consumer products using that.
I don't mess around a ton in molds anymore, but at my old job, we did a lot of car key fobs.
Yep.
And that had an enormous amount of that. And what I especially loved is we worked with a company who under their umbrella had like every price tier of car you can imagine. And oftentimes it was all the same plastic, but like it just came down to like mold texture, and literally a piece of metal to make it feel heavier was the difference between like the cheap economy 4-cylinder and the, high-end sedan.
I came across that recently. I came across some sort of fob that had a big chunk of metal in it. And I'm like,
yep.
Really?
It's heavy. It must be good.
Well,
so I love that mentality.
When I wear my other hat and I'm doing antenna design for these guys, it's like, why is that piece of metal there? It's like, yeah.
A lot of that old school texturing though was done by hand. Like they'd put films on and etch it by hand with chemicals.
Wow.
And that's another one where very labor intensive, a lot of dangerous chemicals. And so like the second there was a technology solution to not do it that way anymore, everyone jumped to laser.
Amazing. So if you guys have questions, pop them into the Discord or YouTube chat, as we are at the top of the hour, and we're sort of on somewhat borrowed time here, and we'll get Adam to answer them. I feel a little more confident about getting myself a ball nose end mill and a piece of Rockwell 58 steel and trying it.
I would say if you have just like a standard, 1/4 inch with a 20 or 30 thou corner radius tool and mill in your collection, you can chuck it in your machine and say you're trying to make a cavity, just taking like 30% the corner radius at maybe 100 to 200 surface feet. You're not in a hurry if you're doing this.
Okay.
And a low chip load between 5/10 and a thou. You'll get some kind of result, and it won't be that bad. It's when you get up above 60, like all of a sudden, okay, now we need something with a more sought after coating for this kind of work, or the cutting geometry needs to be a little more robust. So one of the things I worry about when I get like 58 and above, it's not so much the milling, it's the hole making. If I have to do hard hole making, I get that gets a little tricky sometimes. You see like depths where hard drilling is just going to be a problem.
Yeah.
And maybe you can wire EDM it or something like that. Hard threading, it is not without its problems. I would sooner thread carbide than I would like D2 at 62 Rockwell. It just tends to get a very glossy surface, and your gauge might be a little tight, and you think, okay, I'll just comp 5 more tenths and run it again, and it's like it's just iced over, and you're not getting under it again. It's very peculiar. So,
well, I'm encouraged to go try it and see what happens. Dale says, we've all plowed through a vice jaw or a 1-2-3 block. That's hard milling, and it works fine.
Yes, it is. Yes, it is.
That is very true. Okay, you know what? I think we did it. Is there anything else you want to cover?
No. I just wanted to kind of demystify it as much as I could. It's really not that big of a difference. It's just the tools are a little more optimized for getting you good results.
Well, you did that's the perfect word. You did demystify it. I appreciate it. And one request, Adam, those magnificent drawings you make of your visual examples, please save them. If you're looking for clutter credits, send them my way. I've got walls. I will frame them and hang them. They're magnificent.
I'll mail them down to the Smithsonian. How's that?
I'll get you the address. Evil says scan and publish. Yeah, we could do that. Or I could shoot them. I could set them up and do a photocopy. A literal photo copy of it, and we could put it up there. And then if you sign it, you could be the next machining Banksy. With your
there you go.
All
Get some stencils and go spray paint in mills.
Exactly. Adam, thanks so much for being here today. I appreciate it, and I'm sure everybody else appreciates it. And we'll have you on again. Let's see, where are you? You're over here. There you are. We'll have you on again and keep teaching everybody. So without further questions, we're going to head over into the after party roundtable where we have finger sandwiches. We decided that our standard sandwich now is pâté de foie gras, and that'll be waiting for you next door.
All right.
Thank you very much, Adam, and everybody. Have yourselves a great weekend. Remember to get flat, stay flat, and we'll see you next week.